To solve this linear equation, I'm going to start by distributing the -1 into the parentheses, this 2, and this 4 into the parentheses as well. So the left side of this equation is 4x, that's minus x minus 2, that is equal to -2x plus 8 plus 4x minus 4. Okay, next I'm going to combine some like terms. So on the left we have 3x minus 2. On the right we have 2x, and that'll be plus 4. Okay, from here we can't simplify the left or the right any further, but I can subtract 2x from both sides. 3x minus 2x is a 1x, so I'll just put x minus 2 is equal to 4. And to get x by itself, I can add 2 to both sides. And that gives me the solution, x is equal to 6. And that is it for this problem. Let's solve this quadratic equation by factoring. To do so, one side has to be equal to 0, so I'm going to start by subtracting 36 from both sides of this equation. When I do that, I get x squared. I'll put the minus 5x first, and then minus 36, and that is equal to 0. The reason for doing this is, if we can break apart the quadratic into two linear factors, we can check where those factors are 0. So we have to have an x and an x. It has to be a positive and a negative. I know this because the last number is negative, and the product of these two numbers gives me this -36. So now I'm focusing on this -36. I need two numbers that multiply here, yet add to -5. So what would those two numbers be? So just thinking about the -36 off to the side, a lot of options. Like, you could have a 1 and a 36, make one positive, make one negative. That definitely won't work. Let's see. I think 4 and 9 is a good choice. The product of 4 and 9 is 36. And I think I'll put the negative with the 9 and the positive with the 4. Let's see if that works. So that is x plus 4 and x minus 9. The product of these two numbers is -36, and the sum is -5. This is it. I can now take each linear factor, one is x plus 4, the other is x minus 9, and set those equal to 0. And where they're equal to 0 are solutions to the original equation. So in this one, I'll subtract 4 from both sides, and that gives me the solution x is equal to -4. And in the other equation, I'll add 9 to both sides, and that gives me the solution x is equal to +9. So there are two solutions to this equation, and here they are. To solve the absolute value of 3 minus 2x is equal to 1, I'm going to set this up as two separate equations. One is, where is 3 minus 2x equal to +1? And also, where is 3 minus 2x equal to -1? A +1 and -1 in absolute value make this equation true. Over here, I'm going to start by, subtract 3 from both sides. This gives me -2x is equal to -2. Then I can divide both sides by -2. And my solution is x is equal to +1. The steps are almost identical in the other equation. I'll still subtract 3 from both sides, but it's going to be slightly different here. -2x is now equal to -4. And if I divide both sides by -2, I get that x is equal to, the negatives cancel, and 2 goes into 4 2 times. These are the solutions to the original equation. Let's solve the inequality 5x plus 6 is less than or equal to 7x minus 8. You could go about this in a couple of ways. You could subtract 5x from both sides. I like to have the x's on the left, so I'm actually going to subtract 7x from both sides of this inequality. And when I do that, I get -2x plus 6 is less than or equal to negative 8. Now what I can do is subtract 6 from both sides of the inequality, and I get that negative 2x is less than or equal to negative 14. The last step is to get x by itself, divide both sides by negative 2. And we got to be careful here. I now just divided both sides by a negative number, and that will have an effect on this inequality portion. The left side is x because negative 2 cancels with negative 2. On the right side, negative 14 divided by negative 2 is positive 7, but the inequality is going to be greater than or equal to, not less than or equal to. So this is the solution to the original inequality.